In this video we're going to go back over transformations of a function using matrices, which has come up on the exam from time to time. It came up on the 2010 exam 1, so we're going to look at that question now. So we've got a transformation defined here, and we are going to transform this curve. So we've been told the image of this equation here, y equals 2x squared plus 1, under this transformation t has the equation y equals ax squared plus bx plus c. So we're going to use this transformation defined by this matrix equation. We're going to apply that transformation to this curve, and we're going to rewrite that new equation in this form. So let's do that over here. So let's just write down what we want to do here. We're going to transform all the x and y values that sit on this curve, and we're going to transform them by, we're going to create a new image of each of those x and y values by multiplying by this matrix and then plus negative 1, 4. Okay, so here's our question. So we want to transform this equation using this this transformation as described by this matrix equation. So what we're effectively doing is taking all of our old x's and y's, all the x and y points that sit on this function, and we're creating a new image of them, and we're going to call the new image x dash and y dash. So so what we'll actually get is the new image of x and y. The new image of x and the new image of y will be found by firstly multiplying these two matrices together, which will give us 3x and 2y, plus negative 1, 4. So we end up with this. And if we add these matrices together, we get this. So the new x, all of the new points, the x values of those will be 3 times the old x value minus 1, and all the new y values will be 2 times, all the new y values will be 2 times the old y values plus 4. What we need to do with this information now is to get old x and old y by themselves. So I'm going to set up two little equations over here. So this is really just a process that we have to follow. So we've set up an equation where we've got new x and new y over here, and something to do with old x and old y over here. We're now going to let these elements of the matrices equal each other, and we're going to get old x by itself, and we're going to get old y by itself. And what we're going to do now is take this and put it into here, and we're going to take this and put it into here, and we're going to then transform this equation. It won't look like this anymore. It'll have something put in for y and something put in for x, and then we're going to have to make that equation look like this as required by the question. Okay, so let's go down a page, give us some more room to work in. So where were we? We were here, and we're going to replace the y. Here we are. Okay, so we're going to replace the y with this y minus 4 on 2, and we're going to replace the x with x plus 1 over 3, all squared plus 1. So it's now a case of taking, so this is the equation, where do we go? This equation is the transformed equation, and we now have to get this into the form. So we basically have to get y by itself. We have to sort of tidy up this side. So this is really just a bit of algebraic work. So let's start, I think, by expanding out this. A little bit messy. Okay, so it's 2. Now we multiply the top here, so we're going to get x squared plus 2x plus 1 over 3 plus 1. 9 on the bottom, because we did the 3 times 3. So 2x, and I'm going to expand that 2 in. Now there's a few ways you could do this. This may not be the absolute quickest way, but let's run with it. So we've got y minus 4 over 2 equals this. Okay, what I think I'll do now is multiply that 2 over. So y minus 4 equals 4x squared on 9 plus 8x on 9 plus 4 on 9 plus 2. So I've just multiplied that 2 over. And now I'm going to add the 4. And now I've almost got it in this form that I want it in. I want it in y equals ax squared plus bx plus c. I've only got an x squared term, one x squared term, so that's good. 4 over 9, so a is 4/9. I've only got one x term, so b is 8/9. And my c term is the sum of 4/9, 2 and 4, and because it's written this way, it's probably easier just to write it as 6 and 4/9. If I wanted to, I can convert that to an improper fraction, which would be 58 on 9. So there is an example of how we do transformation using matrices, and we just follow this process really each time.